This video is on NSIGII. NSIGII is spelled N for November, S for Sarah, I for Indigo, G for Gold, I for India, I for India. Today's video is on the NSIGII software development tool. Again, it's an NSIGII software development kit. I'm gonna do it in the way I know it. This is the architectural blueprint diagram, which are not rubber from the boat. So let's do it now. NSIGII is a humanitarian protocol. So you're gonna have human in the loop. Human in the loop is a protocol specification that human has to be in the loop to make sure it's food, water, and shelter are delivered. You're gonna have human in the loop, which means humans are part of the protocol itself. They are in the loop. They are active systems. They are nodes on the protocol. They do their job. They're like kind of systems. They are part of the agentic model. But this video is gonna be focused on humans in the loop, humans out of the loop, humans out of the loop, humans in the loop, humans out of the loop, which can be intelligence like AI system. It's called OBI, AI. Which stands for ontological Bayesian intelligence, artificial intelligence, AI extensions, I'm gonna have human in the loop, human on the loop, and human on the loop. So human on the loop. On the loop. Humans like third party humans or services that can work with the NSIGII protocol. So you're gonna have human in the loop, human on the loop, and human out the loop. So the out the loop is ontological Bayesian AI assistants, agents, and human on the loop. Human on the loop is third party services or third party actors, third party actuators that offer services. But the NSIGII is a transmitter, a receiver, and a verifier of services. And so again, this is what is supposed to use those parts. In case, for example, you can use a verifier as a broadcaster. You can use the receiver as this model can be used to model broadcasters based on really how you wanna verify a node on a network. But the core principle remains the same. You see, the human rights protocol. You send information, you receive information, you get information, and you verify the information. The goal is to have a system of here and now, there and then, when and where, encoded by consensus, and operating on a heterogeneous, homogeneous lattice. Is that correct? Yeah, I think so. But the main principle I want to address is the software SDK stands for software development kit. The NSIGII SDK is in Python and Python and Python and Python for C and Python, C and Python together, Python. We're gonna have a solution. You're gonna have three solutions. So you're gonna have via the framework of human rights. You're gonna have everything is a service. NSIGII offers services that can be hot swapped. So these are services that can host them, and they are. If you think of a dialing, calling someone, and you're locked out of service. When you're locked out of the service, you are hot swap. That's what hospitals are about. If I say I was in a restaurant and I ordered some food, Now, I now call now my table has a number, a number. I'm on number 13, and there are 20 tables. If I order fill and ding my bell, I expect everyone to know that's number 13 that I'm calling from. Number 13. If I go to if I'm logged in, I do tap bell, number 13, and they should know it's not number 20 or 15. But 20 or 15, I mean that this is the everything this number says ordinal. It's ordinal. So by the concept of services, if I want to swap of services, the concept of hot swapping is like, if I take the same bell to number of 15, I should still, it means to get I have to get an extension. That's the beauty of an extension that dictates that I've got to number 15. Because you say you can 13 A and B, 13B. So 13B will mean that my order needs to number 15 table because there's some kind of issue of system. So if you have A meaning 1, B meaning 2, 13B is a codec for me going to table number 15, which is a free table. Assume it's a free table, but that has to be registered. That has not been registered. So the service state sparse or ecologically friendly. If this was number 13, you can shuffle based on alpha and numeric pairs. So A represents 1, B represents 2, C represents 3, A to F. Because there are 20 tables. The 20 tables. So 20 tables: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. So A to T is 20 tables. Now, depending on how of shuffle you need, you go to 1, so something with 13. So if I do 13 B, 13, 15, 13, 14, 15, and now I'm to go 15. And that's the idea of hot swapping. You're now basically the computer now, because I'm trying to understand this concept to you. Basically, it's more of a hotel thing. It doesn't look into your service, it doesn't look at our service. It's more of a sparse use case model. I'm just modeling this. This is a huge big deal about computation system. Actually, I have to make a video then. Actually, it's hot swapping or hot swapping. You hot swap services, and services are where the food you ordered. For example, you're gonna have being in a restaurant, being in a hotel and dining and pressing the reception bell, and or reception, hotel. Say you're now in a hotel, and the hotel has 30 rooms. Your room number is 29. 29, and then you are now. You have so when you call your number, when you call the hotel phone number, you dial the station number #29, and you get your services moved. So you want to move it to basically the same concept works. So you dial the hotel number is hotel is plus 1 2 3 5 6. Just be 11 digits. 9 8 2 1 1 2 3 4 5 6 7 8 9 10 11. So this would be 9 to 11 digits. So basically, say the hotel number is 2 3 4 5 0 1 2 6 9 1 2 3 4 5 6 7 8 9. So there are 9 numbers here. Now, if I add #29, or dial station number 29, this means I'm talking about room number 29, and my service is always faster. So I can get a service faster because I really know I can really index the service. It's like dialing a system of dialing the system. Basically, this is alphanumeric here, and this is because I just swapped tables and one table was free. you got this one here. So this thing, if it was out the hotel, if it was out the hotel, but if it was just in the hotel, because the service internal, basically it's an internal representation of the system. The same thing here I'm trying to illustrate. A little bit of here, but I'm not really sure. You have 29, you have the full hotel number plus 234 501 26 9 hashtag 29. 29, which basically represents number 29 for the service 29. Everything that's happening to that, moving in, getting out, getting to the hotel, getting out of the hotel, if you lock yourself out of the system. And this part of what room you call for, there's a service for that room. And you can always get a service by bringing the right extension. So this 29 is an extension of the number, this B is an extension of the service. So B can be the service extension that to move to, so it's just one number, but it's a number, but move because it's short for reason. The B was an extension of service here. So basically B, so you get 13B. So I was on the restaurant example 13B. So B is a service, B is a service extension. And B represents moving to table number 15 to by adding 2, because it's alphanumeric. Alphanumeric. And these are all extensions on the system. So it can be an entire service or entire system, but it's just a service that stops it being fragmented. So that's what it stops being stale. It's a stale system. So you can hot swap the services too. You can swap component A for component B. So you can call, so if you want B, if B is not working, if B is being used, you can swap it for C. And seasonal service can be used basically, because it can be a service on the same thing. But B is a service, it's not just a number, it can be a service that inside something. So next is next. So 20, yeah. So what is this? You're gonna have the NSIGII big work like this. So NSIGII will have to you have to start something about NSIGII. So NSIGII now is based on the protocol. We're gonna have NSIGII bindings, which are squares, which are all four sides, 4 equal sides. They are bidirectional foreign function interfaces. So they flow both ways. So you're gonna have if you think of them as developer and API developer as consumers and service people use the service from so people use the services go left. Basically, people that use the services are squares. So they use the services, and people that consume them by APIs, by code APIs, are going right. Are going right. They are consuming it in a amplified of back and front. But 2 ways to do that. 2 ways to do that. So one side of the square represents going right. And once I'm going left, making the API code, consuming and making the code. And going up and going down are what consumers do. So they go up and down, and this is what the square does. So the square model is like, bidirectional front function interfaces to the NSIGII protocol. And you have rectangles. Now, rectangles are 2-way FFI. So 1-way FFI. So basically, it's the parity. So you can have bidirectional FIs, but all squares are rectangles. Not all rectangles are squares. All squares have 4 sides. Not all rectangles are all the 4 sides are equal. So you want to have a pure FFI and this is a pure FFI. This is a pure FFI. But if you're not providing the service, you have to provide the service to the food you want to shelter. So you have to provide the UI interface, UI UX services to the NSIGII protocol. You're gonna have 4 sides to the picture of the side of the what's happening there. 4 sides equals 2-way. It's a 2-way FFI, but it's more tailored to a service like a receiver end, which is basically it's still 2-way FFI, but it's more tailored. That's what I'm saying. It's not that it's more than So that is not pure, like pure function. It's just that it has to be mapped to something. The mapping is a two-way, but it's just that it's a driver. So this is a driver. So this driver it's a binding, it's a driver. So also so this driver is a driver. So it runs code. So this is what I'm saying. It runs code. Now, the same with the one more thing. So the driver is rectangles in space of the triangles, and the system here. So NSIGII has bindings, drivers, and extensions, and plugins. So you can have a binding extension, a binding extension, a driver extension, a driver plugin, and a driver extension. That's what I'm saying. So for example, so you have a driver a plugin, a driver extension, which are different to the system. You're gonna have bindings, drivers. Now, the driver is very important to understand. You use it when you have two main entry points. So if you're setting up a program with two main entry points, like they're peer-to-peer topologies, you have two main.exe A.exe and B.exe. These are peer-to-peer topology. So basically, the goal is to have a decentralized, distributed model. And how we see it is very smart. So you have a peer-to-peer topology. You have the box, ring, and star, etc. And these are all what very important in standards, guys. So you have a circle. A circle is basically a job, kind of task, a primary task. No. Sorry, a circle is a primary task, and X is a secondary task. A primary task and a secondary task. So in a peer-to-peer network, you have a circle printing two-way, both ways, to an X. You have this diagram. So you have a circle on one end, which is a main.exe or A.exe, which handles distributed load, distributing of the work over a worker, distributing workers. Oh, sorry. Sorry. So you have the main.exe, which shows a primary task and then a secondary task. Well, this is a primary task. So one server does a primary task. The other server does a secondary task. And that's in the X. That's those nodes and process. Nodes and process. This is a peer-to-peer topology. And it's basically an edge computing node that can scale. Every program in a driver context can be an edge computing node. So you can have a peer-to-peer node, which are basically another node to compute based on the services. This is a primary task, secondary task. Secondary also. We have a cluster of systems working together to provide kind of coherence and system. I'm just moving closer. You have a peer-to-peer. This is called a peer-to-peer node, which is together with a bus, a ring. You have a ring topology. This is what the ring topology. But it's gonna have different types of. This is about the topology. The system has to respect the pictures are made. In other words, let's put the main program, the main entry points to the program. Now, the main entry points can be both for the terminology have, but can be monoglot, polyglot, or hybrid. Or they do a certain job based on what was the task or scheduled. in the operating system. So SIGI delivers food, water, and shelter on time. So the very important thing to understand is a network topology that's distributed and decentralized. There's no one point of entry. There's two entry points. So if one handles food, one handles water allocation, one handles shelter. These are the three ways. So I prefer this one better. But we are conscious to it, so we can switch their roles, you see. We switch the role between even food, water, and shelter. Yeah. Food, I give food today, I give water today, I give shelter today. Or basically. So I give shelter. Shelter is a square. Shelter is square. So circle is triangle, circle is food, X is water, and square is stripe, square is shelter. And shelter represents nodes. We said three executable. So executable A is a circle, executable B is a node cross, executable C is shelter, square is shelter. So now to go there, this is a peer-to-peer topology. And this the edge computing node via worker. No matter where you go, it can scale with edge nodes. That's good. Let's see if I can address those kinds of topology. So let's go back. So you're gonna have kind of a hybrid mesh too. So you're gonna have a hybrid mesh too. So this is what the driver is going to do. The driver is going to have kind of topology there. So the hybrid node, you're going to have a star or a distributed star, but this is what will hold and never lose. So this is like doesn't matter where the server is, server here, server A here. This space is like the flight power, physical space. It can be flying around. And you can get force yourself. So the star mesh, you're gonna have primary square, secondary water, the tertiary house. You're gonna have the inverted on the kind of other way, version of the star. You're gonna have this kind of model. So primary is food, secondary is water, X, and short is triangle, short term. We're gonna have services extensions that work together via hot swapping. Hot dialing, not hot swapping. Hot dialing, which is the hot dialing on swapping services. Hot swapping services, hot dialing. Yes, that's what I'm saying. Last but not least, you're gonna have the data, the packet data, software. We'll try it out on sovereign because it's an IoT protocol, it's an Internet of Things protocol. And Internet of Things protocol is one of the areas. So you can have Internet of Things there. So the IoT services are we tested too. So what are the IoT services? The IoT services are in SIGI, not a problem. Never a problem. Which does with problems in SIGI for food, water, and shelter. You're gonna have a problem. You're gonna have SIGI. So this is never a problem. So there's no problem with food, water, or shelter. It has to encode that, machine does it for you. So you're gonna have robots, drones that deliver food, water, and shelter, and you're gonna be flying around doing topology. So in topology, such as the space in between the meshes, so you can use with space. Space basically what the whole flight path is doing. So you're gonna have drones, you're gonna have robots. Deliver food, water, and shelter free of charge, and you have the mesh topology. So Then have drones that have free shelter and do all the heavy lifting and all the hard work of the security with very policy. And we'll begin that free of charge. We're gonna have mass solution of this. You're gonna be gonna have drone delivered drones, drone delivery robots. Well, however, this is the job. Drone delivery robots that will deliver food on a shelter. And can have them deliver food on a shelter by delivering by going to the flight path. So you're gonna have a flight with a drone, and they'll follow up. Basically, the whole drone get hacked, and I don't want them to. So not the problems we do the problems of the NSIGII, just try to do in code. So if you understand the NSIGII SDK, or not a problem, this one software development kit. Let's put NSIGII and SSR IPv4, if you go IPv4. Software, not a problem, never a problem, never a problem. So any kind of problems here, this kind of telemetry interface. Telemetry interface for NSIGII. For the active actual terms modules, you need to inspect and you look at to see how to debug the system that's working and we can have NSIGII. So this part we are on the Internet of Things, the IoT term, the IoT cell. So we also like Internet of Things. Doesn't matter if it gets hacked or not. You not want to do that kind of problem. Anyhow, not a toy. Not a toy. It's food. It's not a toy. It's not meant to play with. So, not a toy is it's just not a toy. That means it's played with. That means it's dangerous. So things that are so be the robotics interface. The robotics interface. The hardware itself. The software for the hardware, the IoT connection, the Internet of Things connection, so the flying, the drones, you're gonna have not a weapon. So it's food, not the weapon. You can eat the food. So this is not the weapon. It doesn't use food, water, and shelter. Food, water, and shelter. And so there's three software development kits of the NSIGII. A price of it's an IoT service that gives you food and shelter. So good thing to take the remote physics and modern and physics system. Like being only you trying to get food, it's impossible, And this is the problem with the mobile problem I want to express here. So NSIGII is not a weapon, not a shot, not a problem. It's never a weapon, never a toy, and never a problem. So never a problem. So it should just work for anyone who's one of us. But I want to show you what kind of problem that I've encountered while building a system. Lattice. Okay, let me go here. Let me start here. Papers. Can I show my computer? Yes. Let me show you the problem. So this is papers. This is my work here. So basically, for it not to be hacked, there's a lattice space defined by the topology. And this is what I called you lattice space. So this lattice space is basically a subnet mask. So it's basically because it's a routing algorithm in time. This is a lattice subnet masking protocol that ensures there's an order to the system before any kind of takeoff drone, any kind of takeoff is done. Basically, you have a wild because you have a wild area network, a wide area network, and the wild area is basically the space between the topologies. Like if a peer-to-peer tomography is area of space between them. So the lattice is basically the subnet. The lattice is basically the space in there, and that lattice is basically dimensional lattice. So you can have work in XYZ. So the subnet mask allows no one to connect to that lattice while something is taking off, while the drone's in the flight. So the lattice subnet masking protocol is one protocol invented to do with the potential access control in the topology. Like, your Wi-Fi can't connect to the system because the subnet is not allowed. The subnet mask is not allowed you to connect because the subnet mask has been eradicated. because you cannot connect to a system that doesn't that knows directly how to connect. So think of a dome. You're inside a dome, and the dome doesn't allow you to connect because there's no way to connect to the dome. And that's what I'm telling you. The dome will not allow you to connect because there's no way to connect. It's just cut out. The wire is cut out, and so you cannot take out a drone that is flying. So the lattice subnet master protocol. So this is the SIGIS specification. So here, let's go through it properly. So you're gonna have this document for Organized Lattice Subnet Masking Protocol, LSMP, a geometric network access control framework that enforces physical position credentials rather than IP-based authentication. The protocol partitions a circular coverage domain in 45 degrees sectors, subnet A through subnet H, arranged around a central core node, which is basically routing between nodes is governed by A star, shortest path. Load is used with a diagram centrality scoring, and subnet membership is determined by positional substitution type derived from closed open topologies. Devices outside the geometry cannot obtain a network access regardless of the IP address, masking proofing structurally irrelevant. So this is a very key argument to understand. So you're gonna have the design motivation of this system is sort of something to stop connecting something that cannot be that's not meant to be free. It's not meant for you can't get the free. Doesn't matter how far you are from the network, you cannot get the free. It's not meant for you, it's not meant for anybody else. So the dome model. So this is the V1 specification. Let's go to the 8-sector hierarchy. So the 8-sector architecture, that is partitioned into 8 sectors for 5 degrees arranged around the central core. Note, each sector hosts a subnet A to subnet H. The sectors allow the angular position, which are geometric centroid, making the sector boundary of a function of a bearing rather than of an angle of bearing rather than an IP range. So to connect to something, you have to use a bearing system, basically. So subnet A core is a central authority node. Also resolved through the core, acts as a central node of lattice DOM. So really think of the core. I'm trying to still eliminate this core, but this is really good. The core. This is really good because it does what it does. So the core is basically the core functionality of the system. But if everybody knows the core, they have to wait to come. This is still symmetric. If the core gets hacked, but I'm just talking about the asymmetric core. So the asymmetric core, but you still need a core in my framework. So the primary access of the subnet group is upper 0 to 45 degrees, and then for 39 degrees, you have negative for 41 degrees. And so the SIGINT needs to encode system. So this is the problem here. So you're gonna have upper right sector, primary access point anchored left of 0 to 45 degrees, gateway for authenticated lateral connection. And you can have an upper right sector of 49 to 50 degrees, such as access point hands over routing software A. Upper left sector 90 to 135, manage ingress of a previous incident access. Left sector 135 to 118, host network configuration services. Left lower sector 185 to 255, handles monitor and temperature streams. Lower sector 225 to 270, reserved for auxiliary and perimeter services. Lower right sector 270 to 215, East Final terminus, used for cross subnet protocol shortest path resolution. And right sector subnet H 135 315 to system. That's just centrally compute low distributed across all lattice. So let us do work in groups. I'm trying to go here. So this paper is very stamp. It really mapping to a lattice. This is like a anti-spoofing properties of the system. But I'm trying to open this in kind of open with. You don't care for me. So maps to none, zero maps to null. So you're gonna have closed and open to loop topologies. Hyperspace regional modes. So this is what I'm saying. So it's what's kind of a system of ensuring that it works, but it's basically unilateral functional mode of system. I just said this word. So I just each function is which divide or regions based on time, relative to one sector. So without impose growth, you lose connection based on how it's flying. What you do is flying to the drone and all, or it's working because it's routed to that system. But this is my networking because I'm a networker. So let's just do this. Dashboard centrality, each stuff. So this is the routing protocol. So each stuff file storage important. Then dashboard centrality for load resolution. And basically, you're gonna have a peer-to-peer resolution of local nodes, which is called dashboard centrality algorithm. And that's not gonna work off this kind of framework here. Let's go now. What's the time now? 35 minutes. Okay, so I'm gonna end this video now. NSIGII is not a toy. NSIGII is never a toy. It's never a weapon. And it's never a problem. Let's develop the SDK.